Scopes charge 73 nanocoulombs each. Nanocoulombs plus 73 nanocoulombs. They're 0.35 meters apart, so R equals 0.35 meters. We need to find the force acting between them. All right, so calculate the electrostatic force acting between them. Is force attractive or repulsive? First of all, since they're both positive, it is going to be repulsive. So Fe equals K Q1 Q2 over R squared. All right, so 9 times 10 to the 9th newtons times meters squared per coulomb squared times 73 times 10 to the negative 9th coulombs times 73 times 10 to the negative 9th coulombs. It's nanocoulombs. So nano is times 10 to the negative 9th. Micro is times 10 to the negative 6. That's always good to remember. Divided by 0.35 meters squared. Now, we just have to go through the act of putting this all into our calculator. So, I like the double E button. So 9E9 times 73E minus 6 times 73E minus 6. All right, divide that by 0.35 squared. You didn't need to hit enter in the middle. Oops, I put the wrong numbers in here. See that? It's E minus 9 divided by 0.35 squared. 0.0 Fe equals 0.00039 newtons, or 1, 2, 3, 4, 3.9 times 10 to the negative 4th newtons. All right. Just make sure I did that right there. 0.35 squared. Okay. All right, next one here. Big plate covered in excess electrons produces an electric field. So, I don't know. I guess I'll draw something covered in electrons. Makes an electric field. All right, those field lines all go towards it. All right, the E field strength is 20,000 newtons per coulomb. Determine the force the plate of charge would apply to a 10 microcoulomb charge, so plus 10 microcoulombs. All right, so Q is plus 10 microcoulombs. F equals what? All right, so electric field strength equals force over charge. Multiply both sides by the charge. You get F equals QE, or F equals plus 10 microcoulombs. But wait a minute, we got to write this in scientific notation. Be careful. Because look, microcoulombs and coulombs don't cancel. So we have to make this 10 times 10 to the negative 6 coulombs. So the force equals 10 times 10 to the negative 6 coulombs times 20,000 newtons per coulomb. So then the coulombs can cancel, right? So it's 10 E negative 6 times 20,000. That's going to be a force of 0.20 newtons. This one here, electric field caused by positive charge. Positive charges, the field radiates outwards. Like that. All right, now, questions I did in class today, I added to this worksheet, so it's a little bit longer. Force of 10 newtons acts on an unknown object when it is 0.5 meters away from a 200 microcoulomb charged object. Determine the charge of Q2. So, we know the force, we know the radius, we know Q1, we don't know Q2. So, Still the same equation, Fe equals K Q1 Q2 over R squared. We know 10 newtons is the force. K is 9 times 10 to the 9th. Newtons times meters squared per coulomb squared. Q1 is plus 200 times 10 to the negative 6 coulombs. Q2 is unknown, divided by the distance between them, 0.50 meters, and that's squared. All right, so 9, well, I guess first thing I'm going to do is square that 0.5. 0.5 squared is, right, 0.25. So I multiply both sides by 0.25. 0.25. All right, it's going to get rid of that and that. So you get 2.5 equals 9 times 10 to the 9th times 200 times 10 to the negative 6th. Q2, so I'll multiply these two, 9 times 10 to the 9th times 200 times 10 to the negative 6. That's 1,800,000. All right. Divide both sides by 1.8 million. All right, Q2 equals 2.5 divided by, that's 1, 2, 3, 4, 5, 6, 1.4 times 10 to the negative 6 coulombs, or 1.4 microcoulombs. And then the electric field strength where Q2 is located. So there's some sort of electric field here, right? It's due to this charge here. Electric field strength at that location is the force at that location per unit charge. So the electric field strength is whatever force is acting on that, 10 newtons, divided by whatever this charge is. So it's 10 newtons of force per 1.4 times 10 to the negative 6 coulombs of charge. So the electric field strength is 10 divided by 1.4 6. It's about 7.1 times 10 to the 1, 2, 3, 4, 5, 6. 10 to the 6 newtons per coulomb. It's a pretty strong electric field, and that's that.